Alright, today we are reviewing Chapter 9 for our test tomorrow. The first set of directions tells us that we have some variables that vary inversely. So you need to remember the inverse relationship is y equals k over x. So just as it was not provided on your review sheet, it will not be provided on the test. So you need to know that an inverse relationship is a division relationship. Y is equal to k divided by x. The directions tell us to use the given values to write an equation that relates x and y. So in the first question, we'll plug those numbers in for x and y and find out what k is. So multiplying both sides by -2 gives us a k value of 4. But that's not what the question said. It didn't say find k. It said write an equation that relates x and y. So an equation that relates x and y should have x and y in it. So that equation would be y is equal to -4 over x. K alone is not a solution. K plugged into the equation is a solution. Still having x and y in there, so it tells us how x and y are related. The next sentence of the direction says, then find y when x is 4. So that gives us a second thing to do, that now that we have the relationship, we can plug in a new number of 4 and get a solution of -1. So two separate things we're asked to do, so we need two separate answers. The first one is the equation that has x and y and the number that we find plugged in for k. And then the second answer is what we get when we plug in an additional value for x. Questions? We're going to skip past number 2 for a moment and go on to number 3, where the directions are pretty similar, except we're told that we have a joint variation. Joint variation is z equals kxy. It is a multiplication relationship by more than one variable. Otherwise, the directions are pretty much the same. So we're going to start by plugging in the numbers. -2 for z, we don't know k, 2 for x, 8 for y, and finding out what the k value will be. So -2 is equal to 16k, and dividing by 16 gives -1/8 for k. But I'm not going to box that in because the directions didn't say find k. We want to write a relationship between x, y, and z. So that would be that z is equal to -1/8 x, y. Then once we have that relationship, the directions give us another set of points. Says then find z when x is -1 and y is 4. So plugging that in gives +1/2. Okay. So first, an equation that shows the relationship, solving for the particular k value for that problem, and then using the general directions to plug in a new point and find a new value. Questions on either one of those? Okay, go ahead and go back and try number 2 and number 4. Alright, we'll go ahead and take a look at these. So for number 2, I begin by plugging in the given values in the problem to our inverse equation and find what k is. So multiply both sides by 8 and I get a k value of -4. But that alone is not an answer. The answer is what we get when we put that in k's spot in the general equation. This is actually exactly the same. I didn't do a very good job of picking numbers. So for the second part, we would plug in a 4 and get exactly the same thing as we got the first time.
What do you plug in 4 at the bottom? Oh, never mind.
Okay. For number 4, that gives 2 And dividing out by that 2 gives us a k-value of -1/2. Our first answer is the equation with that k-value plugged in its spot. Then for our second answer, we plug in the -1 and the 4 from the directions and get a new solution of 2. Questions on inverse or joint variation? Make sure you know those formulas because these problems are pretty close to impossible to do without them.
Will you have any inversely and jointly ones on?
No, it'll be just like this. I'm not going to combine the different types of variation. We'll do some inverse, some joint, and keep them separate. And no direct. We talked about direct in the chapter, but there won't be any direct.
Is the test similar to this?
Exactly. Yep, the test will be exactly the same as this. Different numbers, so instead of 4s, we'll use 3s, but yeah.
But is it going to be direct?
Direct will not be on the test. It is graphing and asymptotes. For asymptotes, the rule for vertical is that it is where the denominator is equal to 0. The vertical asymptote is the value that would cause us to there's none. If the bottom wins, it's at y equals 0. And if they tie, they both get to play a part. And that would mean that we take their coefficients a over c. So you need to make sure that you know these rules for how to find our asymptotes. So for number 5, it's not really in the right format yet because it's not a divide by 0, and that's a problem. So our vertical asymptote is at x equals 0. For horizontal, we look at the powers of x's. Is the power of x bigger on the top or the bottom or the same? Bottom. The top doesn't have an x. The bottom has an x the first, so the bottom is the winner, which means that that horizontal asymptote is at y equals 0. So we can draw those asymptotes into our graph. And then to graph the function itself, we can plug it into the calculator. So in the calculator, we can type in y equals 1 over x and sketch what we see, which should look like this. I'm going to run through the graphs pretty fast. Since I know what they look like, I'll just kind of draw them in there for us. But when you graph on your the calculator and just sketch what you see, it doesn't need to be okay, but the asymptotes do need to be correct. So for the next one, vertical is the value that would make us divide by 0. So what would make us divide by 0? 1. So vertical asymptote is going to be at 1. If I would plug in a 1, 1 minus 1 is 0, and that's a problem. Now in this one for our horizontal, we have a little something to consider. If we focus on just the fraction part of this, where's the bigger power? On the bottom. So what would the rule tell us then?
0.
Y equals 0. But we don't have just that fraction. We have this extra thing as well. So if the fraction gives 0, but then we're adding 2 in the equation, where should the asymptote be? We're going to take that 0 that we got from here and add to it a 2. Okay, so the fraction gave us an asymptote at 2, but the equation says we're going to bump it up 2 spots from that. So our asymptote's actually going to be at 2. Okay, it's like a shift that's occurring in the graph. Shifting up 2 there. So the fraction that the bottom power was bigger, so it should be at 0. But then the equation has that extra plus 2, so the asymptote needs to add. And once we have those asymptotes, we can plug it in the calculator and find that it's in the same 2 sections as the last one. Questions? Number 7, what would cause us to divide by 0? 4. So 4 will be our vertical. For the horizontal, we look at the powers of x's. Top, bottom, or tie? Tie. And when we have a tie, that means we're going to take the coefficients, or the numbers that are in front of those x's, which are both 1s, and make them a fraction. 1 over 1 is just 1. So we get a vertical at 4, a horizontal at 1. And then use your calculator to sketch it into the appropriate sections. For number 8, vertical, what would cause us to divide by 0? On the calculator that if there's any addition or subtraction that you remember to put parentheses around it. You don't have to on this one put parentheses around the top, but it's kind of a better safe than sorry thing. When in doubt, just throw parentheses around it. It won't be wrong to put parentheses around it. Okay, it won't hurt anything by doing it, but it can mess things up if you don't and you were supposed to. So make sure when you graph on your calculator that you include parentheses around the numerators and denominators. Questions on graphing or asymptotes? Asks us to perform the indicated operation and then simplify. So that means we could be doing all different types of math in here. So pay attention to the symbol. So number 5. a 2 on the top, and an x squared on the bottom. Number 11 is also a multiplication problem, but remember that you cannot cancel a part of an addition and subtraction. So it is tempting at the get-go to cancel those x's that are right in the front, but you cannot, because x plus 2 is a thing altogether that cannot be broken up. So what do we need to do then to be able to reduce this? Factor first. So that second denominator can be factored. What multiplies to 4 that adds to 4? 2 and 2. So then we can cancel whole groups that match. So I can have an x plus 2 go with one of those x plus 2's. Anything else?
You take off one of the x's.
We can take out one of the x's. Since we have some singular x's here, or powers of x's, we can reduce those out, taking the 1 from the bottom away from the top, leaving 4. So the leftovers after that then are x to the 4th on top and an x plus 2 on the bottom. We cannot reduce out one of those x's because that x plus 2 can't be split. Questions? Number 12 is a division question. How do we divide fractions? Multiply by the reciprocal. So we're going to flip over that second one. And change it to a multiplication problem. There's a lot of 3's and x's in here, and it's pretty tempting to just start crossing things off, but make sure you're crossing off legal things. You cannot separate addition and subtraction pieces. So those x minus 3's are groups together, but they happen to match each other, so we can cancel the whole group of the x minus 3's. Anything else?
The x's.
We can cancel the x's, which leaves a 3. A lot of students want to say 2x. Okay? 3x minus x would be 2x. But when we're dividing, we're not subtracting the coefficients there. We're reducing out that matching piece of the x, so it just leaves the coefficient of 3. Okay, so 3x over x is 3, not 2x. That's a subtraction. Number 13 is asking us to add. What do we need when we add fractions?
The same thing on the bottom.
Same denominator, which we have in number 13, so we're set to go. So on the top we can combine like terms, making 7x plus 2. What about the bottom? X minus 2. The bottom does not change. You need a common denominator to add and subtract fractions, but then that denominator is the denominator of your answer. You don't add those together as well. We cannot reduce the x's, we cannot reduce the 2's, because those are parts of an addition and subtraction. Number 14 is asking us to subtract. When we did this in our lesson, I said my first thing is I change it to plus a negative. That's not mandatory. Otherwise, it's just kind of easy to lose that negative along the way. And if it's tied to a number, we tend to stick with it a little bit better. These do not have the same denominator. So we need to get the same denominator. And what do we need to do that?
LCD.
Find the LCD. What do we need to do first?
Factor.
Factor. What multiplies to negative 16 that would disappear?
Positive 4.
Positive 4 and negative 4 will multiply to negative 16 and disappear when added. So then what is our least common denominator going to be?
X plus 4, x plus 4.
X plus 4 and x minus 4. We copy on the old numerators. And any changes that are made on the bottom need to be made on the top as well. So in the first fraction, were there any changes made? No. Both of those were there before, they're still there now, no change was made. In the second fraction, there was a change made. What's new? the x minus 4. So since it's new on bottom, it needs to be new on top as well. We then need to distribute that negative 1. So I'm going to have 8 minus x plus 4 all over that LCD. And combine up like terms for the final answer, 12 minus 2x over x plus 4 and x minus 4. Negative 2x plus 12 would be fine. The order of writing that doesn't matter.
Should we factor the top one?
We could factor on the top. We could take out a 2. It would not be wrong to do that. And it would leave us 6 minus x. It doesn't help us in being able to reduce it all, so it's not necessary to do. But that would be fine to do on the top as well. Number 15 is back to multiplying. So we need to reduce this. It's tempting to cancel those 16s, but we can't because one of them is part of an addition. So we need to factor. How does that first denominator factor? There's a 4 in common, leaving an x plus 4. And the second numerator? There's a 3 in common, leaving an x plus 4. Now, there's lots of things we could do next in terms of starting to simplify this problem. I have a preference. For me personally, I'm going to start by canceling out those groups and just get rid of those that I can see match. But now there's a lot of other stuff in here that can reduce. There's some numbers, there's some power of x's, and they can reduce, and it's not wrong to start reducing them at this point. But I find for myself, and that for lots of students, that if we start trying to cancel too much stuff at once, they'll leave 1 left over on the bottom. So I end up with a 3 over a negative x. Questions on that? Fractions. To simplify a complex fraction, where we have fractions inside of fractions, what do we do to clear them out?
Find the LCD.
Find the LCD and multiply each part by it. What's the LCD going to be here? 12x squared. We need a number that's big enough to reduce out all of the numbers in the problem. So 12, 6, 2, and 1 all go into 12. And we need the biggest power of each of the variables that's present. So since there's an x squared, we need an x squared to get rid of all of them. In the first fraction, the 12 and the 6 reduce to leave 2. The x squareds completely go. So I'm left with 2 times 1, or 2. Minus, in the next fraction, one of the x's goes, and that's it. The 2 and the 12 don't cancel because those are both on top, so we can only cancel what's on bottoms. So the 2 and the 12 make a 24, and then there's an x left over. First part of the bottom, the 12s go, one of the x's can go, So I'm left with a 4 and an x. Second part of the bottom, the 2 goes into the 12 6 times. X squareds go. So 3 and 6 make 18. Questions on that? Before we put a box around it, what do you notice about all the numbers? They're all divisible by 2. So our final answer should divide everything by 2 then to reduce this down completely. You can only do that if everything is divisible by the number. Okay, so if some of them are and some of them aren't, we can't pick and choose what we reduce. But if everything can be reduced, then it should be. Questions?
Why can't you cross off the x? Like, I know if it was just x plus 9, you couldn't, because you just have a plus 9 there. Is there something in front of it?
It just wouldn't work numerically to cancel off the x's. Like if we picked a number and plugged it in for x, it wouldn't be the same thing both ways. So it just doesn't work to cancel out a piece of an addition. It's an order of operations thing. That big division bar is kind of like a parentheses. So for order of operations, we have to calculate the whole top and then divide by the whole bottom. So in the next one, what's our LCD going to be?
3x plus 1.
3x plus 1. So on the top, the x plus 1s will go, leaving 10 and 3, which are multiplied, so that's 30. First part of the bottom, the 3's go, which leaves a 1 times x plus 1. 1 times doesn't make a difference, but if that was anything else on the top there, we would need to distribute that. Second part of the bottom, the x plus 1's go. 2 and 3 make 6. And for our final answer, to clean it up, we want to put together like terms to make a plus 7. Questions on complex fractions? Solving equations. The first one is a proportion. It is 1 fraction equals 1 fraction. So a proportion can be solved by cross multiplying. You could also find a least common denominator and multiply the whole thing by that. But sometimes that ends up in bigger powers of x, like cubic equations. So it will probably be better to just cross multiply. So that gives x times x, which is x squared. And we need to distribute that to, so we're going to get 2x squared minus 36 on the other side. This turned into a quadratic equation, so I'm going to get everything together by subtracting an x squared. There are 2 different ways to solve this particular quadratic equation. Since there is no x term, we can add the 36 over to the other side and take a square root. And what do we get? Positive and negative 6. And that's the risk of doing it this way, is students forget the plus and minus. We just take the square root and we say the answer is 6, and then we lost the solution. So the other way of doing it is to solve by factoring. X squared minus 36 factors as x plus 6 and x minus 6. So then we can see clearly there that there should be 2 answers from the factoring. It's a preference thing, and I don't care which way you do it, but if you solve by taking square roots, just make sure that you're careful of that plus or minus so that we don't lose solutions. Now, do both of those solutions actually work? If I plug in a 6, will I end up dividing by 0? No. If I plug in a negative 6, will I end up dividing by 0? No. So they are both good solutions for our final answer. but double check and make sure that they don't cause us to divide by 0. If they do, they don't really work then. So we would not want to include those in our answer. Number 19 is not a proportion, so we can't solve it by cross multiplying. So how do we clean this up?
LCD.
Multiply the whole thing by the LCD. What is the LCD? X times x plus 4. So the LCD is a really big thing in this chapter. You need it when you add or subtract fractions. You need it for complex fractions. You need it for solving equations. When we distribute that LCD through here, in the first one the x plus 4s would cancel, leaving the 15x. In the next one the x's would cancel, leaving the 5 and the x plus 4. And you also must multiply that 5. Even though it's not a fraction, and it's on the other side of the equation, everything needs to be multiplied. It's just that nothing over there is going to cancel. But it still needs to all be multiplied. So then we have some distributing to do here. You get 5x plus 20. And 5x squared plus 20x. Since I ended up with an x squared in this thing, it's quadratic, I'm going to move everything to one side. So I'm going to subtract 15x and subtract 5x. And also subtract the 20. Okay, and I'm running out of room. 0 equals 5x squared. All those x's cancel each other out, and I end up with just minus 20. What do you notice about both of those numbers? They're divisible by 5, so it's like 0 is equal to x squared minus 4. And now, like the last problem, there's two options. You could add 4 and take a square root, or you could factor x plus 2 and x minus 2. Either way, we get solutions of plus and minus 2. Which, when plugged back in, are both good answers. Neither one of them make us divide by 0. Questions?